So, you might think you know Minecraft, right? But what about teaching an AI to play it? We're not just talking about walking around. We're talking about mastering one of the most complex, wide-open games ever made. Today, we're going to break down how a new approach finally cracked the code. But first, let's get into why this is such a ridiculously hard problem for an AI to solve.
Okay, check this out. In a super controlled setting, like a simple digital tabletop world, AI planners are brilliant. They succeed pretty much 100% of the time. But the moment you drop them into the wild, unpredictable world of Minecraft, look at that number. The success rate just tanks, all the way down to about 23%. That's not a small dip. That's the AI hitting a brick wall. So what is it about this game that makes it an AI's worst nightmare?
Well, it really boils down to two massive hurdles. First, everything you do in Minecraft is part of a long, complicated chain of events. I mean, to get a diamond, you have to do at least 13 other things in the right order. If you mess up just one step, the whole plan can just fall apart. And second, the best way to do something is always changing. Need wool? Well, the right move totally depends on what's around you right now. It's a puzzle that's constantly changing its own rules, and for a traditional AI, that's just impossible to handle.
Yeah, so basically, a traditional AI is like a tourist trying to follow a super rigid, pre-printed map in a city where the streets are literally rearranging themselves every minute. They're just completely lost. But what if the AI could just toss the map and learn to figure things out on its own? And that right there is where things get really interesting. This is where the whole game changes. A team of researchers came up with a totally new way of thinking about this problem. It's a framework that doesn't just give the AI a better set of instructions, it actually teaches the AI to think and adapt like a real, seasoned player. It's called DEPS. That stands for Describe, Explain, Plan, and Select. And honestly, it's less like a computer program and more like an inner monologue for the AI. It's this little voice inside its head that's constantly asking, okay, what just happened? Why didn't that work? What's my new plan? This simple little loop of self-reflection is the absolute key to everything. But the real magic, the secret sauce of DEPS, is how it deals with failure. It doesn't just see an error message and give up. It learns. It has this incredible, built-in self-correction loop that lets it turn every single mistake into a lesson. This is the moment the AI really starts to think for itself. So here's how this little learning dance works. First, the AI tries to do something. If it messes up, it doesn't panic. It just describes what happened, taking stock of the situation. Then, it explains to itself why it failed. And finally, armed with that new understanding, it comes up with a better plan. It's this constant, relentless cycle of try, fail, learn, adapt, over and over again. And you can see this thinking process so clearly right here. The AI isn't just saying error, it's reasoning. It says, okay, I couldn't mine the iron ore because I need a stone pickaxe, which I don't have in my inventory, so the logical next step is to craft a stone pickaxe first. That's a level of common sense deduction that is just, wow, it's remarkably human.
Okay, so fixing your mistakes is huge, but that's only half the story, right? What happens when there are 3 or 4 perfectly good options? Choosing the most efficient plan can be the difference between getting that diamond and, running out of time.
Right, imagine this. The AI needs wood. It sees 3 different kinds of trees. A normal AI might just pick one at random. But in Minecraft, one tree might be right next to it, while another is on top of a mountain swarming with skeletons. So how does the AI make the smart call?
This is where the select part of DEPS comes in. It has this secret weapon called the Horizon Predictive Selector. Think of it like a super advanced GPS that doesn't just calculate distance. It calculates the time and effort it will take to complete a task, factoring in everything from terrain to tools. It's all about finding the path of least resistance.
So the selector looks at the situation. The goal is to get a log. On paper, there are 3 options, but the selector is smart. It sees that the agent is currently in a savanna biome, and it knows that savannas only have acacia trees. So it instantly makes the logical choice, saving a ton of time and energy chasing after trees that aren't even there.
All right, so we've got an AI that can learn from its mistakes and make brilliant strategic choices. It's a master of improvisation. But the real question is, can it actually win? It's time to put DEPS to the ultimate test and see if it can conquer the biggest challenge in Minecraft.
And the results are, well, they're not even close. It's a total landslide. Across 71 different tasks, Deeps hit a success rate of nearly 49%.
Now, to put that into perspective, other cutting-edge AIs, they couldn't even crack 26%. Deep's isn't just a little bit better, it's playing in a completely different league. Yeah, that's right. It's nearly double the performance of the next best thing. This isn't just a tiny step forward, this is a massive leap. A whole new way for AI to approach solving problems in these crazy, complex, open worlds. But here it is, the ultimate mic drop moment. Depps managed to achieve the holy grail of Minecraft. It mined a diamond, starting with absolutely nothing. This is something that has stumped researchers for years, and Depps is the very first planning-based AI to ever pull it off. It's a truly historic moment.
And that leaves you with a really big thought. Because if an AI can learn to handle the infinite chaos of Minecraft, what's stopping it from learning to navigate the complexities of our own world? The lessons it's learning in this virtual sandbox could be the key to building smarter AI for everything. The game is just beginning.